Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials version 6 course, or the Networking 2 course at Anne Arundel Community College. And this afternoon's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 7.4.1.2, the Skills Integration Challenge. And so we're going to be called upon to bring a lot of what we've learned so far in the class all to the fore here in this skills integration challenge. Now the focus is going to be on ACLs without a doubt, but they do throw a zinger here right in at the beginning. So let's take a look at our topology over here to the left. We've got the HQ router, the branch router, and then we've got our addressing table here, which we're going to be filling in. But here is where we start right away. So, I mean, they come out guns blazing here. So they're asking us to divide the 172.16.128.0/19 into two equal subnets for use on the branch router. And the branch router has two internal interfaces here. And so this is kind of our branch address space. And that's what this is referring to at the very top of the diagram here. When you see this branch address space, it doesn't mean that this is the subnet mask for Baker 1, right, or PCB1 here. What it means is for the entire branch, right, for all of this stuff here in the branch, that's the current address space. And our task is to carve this up so that we have one network here and one network over here, but that they are the two equal subnets. Now, I'm going to show you a very, very simple way to subnet these Class B addresses. And here's the thing. When learners see Class B, they typically immediately freeze up, thinking that it's somehow substantially different than when we're working with a Class C type address. So we're going to break this down. We're going to make this very, very simple. And I'm going to start with an example, something that we're very familiar with, very comfortable with, and that is 192.160, and let me pull that back there. My pen just gives out on me sometimes there. 192.168.1.0/24. Now, if I was to tell you that I wanted you to give me two subnets or two equal subnets from that single network, you would say, oh, well, that's easy. It would be 2/25s, right? And then all you would have to do is look at that fourth octet, which is the last octet, which right now is currently all zeros, right? All host bits in here right now. 2, 3, let me count this. 1, 2, 3, 4, 5, 6, 7, 8, right? So all the other bits out here, the first 24 bits, right? These are all network bits. So I need you to create two subnets for me. Well, how do you create two subnets from an individual network? You simply borrow the leftmost bit, the high order bit in the octet going from right to left. This is going to be our leftmost bit. And that is going to solve the problem for us. Now, the question is, okay, well, what are the two networks? Well, remember from subnetting, what is the value of this high order bit position here? The leftmost position is 128. If that is the bit that I am borrowing, then that is the block size right there. If I borrowed 2 bits, the block size would be 64. If I borrowed 3 bits, the block size would be 32. If I borrowed the 4th bit, the block size would be 16, and then 8, 4, 2, 1, right? So again, the block size is 128. And so you know that the first network is going to be 192.168.1.0/25. And if it's .0 and the block size is 128, the next subnet, which is subnet 2, is going to be 192.168.1.128. /25. And we know our first usable is 129. We know our last usable is 254. And we know our broadcast address is 255. And here it's the same thing. The first usable is .1. You know, the last usable, or it's easier to get the broadcast first, it's going to be 127, right? It's one less than the next network ID. And my last assignable or usable is 126. And so there are my two equal subnets. Now, when we do this with a /24, everyone says, yeah, okay, piece of cake. But for some reason, as soon as you put a class B address and a / notation lower than 24, like a 22 or a 20 or a 19 like we have here, everybody freezes. Now, we're going to break this down. It is the same principle, right? It's the exact same principle. So here we go. I've got 172.16.128.0/19. Now, what that 19 means is that the first 19 bits of the address, so 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, right? So we've got 8 and 8 is 16, and 3 gives me my 19, right? So 8 plus 8 plus 3 is 19. So what that means is all the remaining bits, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8. So all the remaining bits are host bits. So if this is the single network I'm dealing with, and it is, because here it is right here, that is the branch address space, and I want to carve this single /19 up into two equal subnets, all I need to do is borrow the next bit. The next host bit gets borrowed and becomes a network bit. And so then what do we have? We've taken this network right here, and I've said, what's the new block size? The block size is no longer 32. If it was a /19, remember, 128, and then 64, and then 32. The block size is now 16. So just like before, when I had 192.168.1.0, this is my interesting octet. With the /25s, that, or with the /24, and we were carving up, that was the interesting octet. So this is the octet I'm interested in when I'm dealing with the class Cs. This is the octet I'm interested in when I'm dealing with the class Bs. And so then the first network would literally be 172, it's right there in front of us, .16.128.0/20. Just like the first 192 network just became a /25. Just like that, right? It was that easy. And so now I know that the block size is 16. So what's the next network going to be? It's going to be 172.16. Now, the common mistake that learners will make is they'll do this. They'll say, okay, .128.16/20. Wrong. Remember, is that the interesting octet where we're doing the borrowing of the bits? No. First octet, second octet, third octet. Are we borrowing anything over here? No, we're not. So that is a very common mistake that learners will make, is they'll put the block size in the fourth octet. Well, remember, just like we looked at this and we said, okay, the interesting octet, we start at 0, the block size is 128, it then became 192.168.1.128, right? So here, where that's the interesting octet, that's where we increment by the block size. But here, we don't do it like this, right? Let me clear the screen. I'll write these out again. So the first network is going to be 172.16.128.0/20 because we've borrowed the next host bit, right? And then the second subnet is going to be, I'm just going to say plus 14 right here. I'm sorry, plus 16, my block size, plus 16, my apologies. So we've got 172 117.144.0/20. So the single /19, 172.16.128.0, when subnetted, right, when turned into two equal subnets, all we do is we borrow the next bit over, and here are my two networks. It is literally that easy. And so then let's take this one step further. What if I was to tell you, right, and I want to show you that this little trick I'm showing you with the block size, that this works. So we've got this network here. So if I was to give you that network right there and say, give me two equal subnets based off of this single /20. I want you to subnet that out and give me two equal subnets that I can use. You would come over here and you would say, okay, so it's a /20. So we've got 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot. Remember, /20 is what we have now. 1, 2, 3, 4. So 8 plus 8 plus 4. That's going to give me my /20, and then that tells me that 1, 2, 3, 4 dot 1, 2, 3, 4, 5, 6, 7, 8. That the last 12 bits are all host bits. So in order for me to carve a /20 up into two equal sized subnets, I simply borrow the next bit. Right? I borrow the next host bit and I say you're now a network bit. So now we have 21 bits that are reserved for the network. And what is my block size? Is it 128? No. Is it 64? No. Is it 32? No. Is it 16? No. It's the value of the bit position which we borrowed. So it's 8. So what would my two subnets be? The first one we know, right, because it's right there. So the first one's going to be 172, and I was going to put number 1 there, 172.16.144.0/21. So as you can see, the network that we're carving up, it stays the same. The network ID is the same. It's the CIDR notation or the subnet mask that changes. So then what is the second network? Piece of cake, 172.16, 144 plus 8 is 152.0/21. And then I could ask you, carve that up. And in fact, we shouldn't even have to work this out. If I were to tell you the second subnet that we just got, I want you to take that network and give me two equal-sized subnets. All you would have to do is this. 22, it's going to become a /22, right? That's a terrible 2 there. But it would become a /22. The block size would be 4, so it would be 156.0/22. There you go. Boom, done. That easy. It is that simple to create two equal subnets when given a single network. And this holds true irrespective of whether it's a Class B address that you're seeing, or if it's a /17, or if it's a /27. The same principle is true. And again, we're all about that third octet because we're talking about these Class B addresses here, right? Now, obviously, if we go beyond a /24 or 23 into a 24 or 25, then obviously, yeah, we're in that octet. However, when we're dealing with these Class Bs and carving Class Bs up, this is exactly how you deal with it. And it makes it so easy to deal with. So let's go ahead and let's sort this out here. So we're going to take the 172.16.128 and I'll say .0. I'll put the network in here, and then the next network would be 172.16.144.0, and they're both /20s. And so the reason I cleared the screen and put this up here is I'm going to leave this up here for us. And actually, I'm going to clear the screen because I just realized assign the last usable of the second subnet to gig 00. All right, so let's do this. So I'm going to leave this up on the screen as well. So here is our subnet. Our subnet for gig 00. We're using the last usable of the second subnet. So the second subnet was what? It was a 172.16.144.0/20. So the block size is 16. How do I figure out what the broadcast address is, or what the last usable address is? Yeah, I do the easiest thing. I simply add 16 to this. And if I added 16 to 144, I would get 160, which means that's the next network ID. So what is the address right before that? Well, it's going to be 172.16.159.255. That's my broadcast address. This is my network ID. My broadcast address, my first usable is .144.1. My last usable is .159.254. And again, remember, we've got how many? 20, so 4, 12. Was it 12 bits left over, I think, for hosts? So we've got quite a few hosts that are going to fall in this range, right? So what is the last usable IP of the second subnet? It is, and I'll just write it, even though that's the subnet field there. I'm just going to put down the IP here. So 159.254 for gig 00, and that's a 4. Oh, that's a terrible 4. All right, so gig 01. Let's drag down here, and I'll do a little squiggly here. So gig 01 says use the last usable address of the first subnet. All right, the first subnet, 172.16.128.0/20. So I know my first usable, that's easy, right? 128.1. But now the question is, what's the last usable? Well, I already know the second network. Remember, this is network number 2 here. This is going to be network number 1. So if it starts at 144.0, I know that my last, or my broadcast address would be 172.16. what? Yeah, 143.255. And then we've got 143.254. And this is my broadcast address right here, and that's the network ID right there, /20. So we have everything we need now to crush the rest of this exercise. All right, so now I'm going to move back into control mode here, and let's actually make this happen. So, and actually, I apologize. Let me write down one last thing here, although it's kind of obvious at this point. The last usable IP is going to be .143.254. Okay, so now we're going to shift back into control mode here. All right, so let's pull up that branch router, which is where we're going to be doing the majority of our configuration work here with the IP subnetting anyway. And I don't want that. All right, let's jump onto the CLI. So we are in user exec mode as evidenced by the greater than sign. I'm going to use the enable command. That's going to put me into privilege exec. Now, I'm going to say show IP interface brief to see what we've got so far. So the gig 00 and 01 are up. We've got the serial 000 interface that goes to the headquarters router. That's up and IP'd, so we're good there. Let's get into global config with the configure terminal, or just conft command. And here we go. Let's get into interface gig 00, and let's see, because we're 0 out of 60 on our points right now on the bottom right. So we should see that if everything I just told you is true, we should get the points for each of these interfaces. So we're going to say IP address, and this is the last usable 172.16.159.254. So it's the last usable 255 address in the second subnet. Now we're dealing with the /20, right? So remember, we kind of already worked this out. There's your 8 bits, the 255 for the first octet, the 8 bits for the second octet. So if 4 of the bits have been borrowed in the third octet, we've got 128 plus 64 gives me 192, plus 32 gives me 224, and then the fourth bit with a value of 16 is going to give me 240. So we're 0 out of 60. Let's see, this should be a 4-pointer if I'm not mistaken. And there we go. So we're at 4 out of 60. I'll say no shut even though it's up. just out of habit. Okay, so that is gig 00. Now let's get into interface gigabit Ethernet 01. And we're going to say IP address 172.16. Now remember, we're dealing here with the last usable IP of the first subnet, which would be 143.254, 255, 255, 240.0, because again, it's a /20. The first 20 bits are reserved for the network. And I'm sorry, I've got to clear a screen here. All right, so we should pick up 4 more points there to move us to 8, and we do. All right, so we are good right now with our IP addressing. And that little trick I showed you, that block size trick, is critical to saving you a whole lot of time and a whole lot of headache. It said document the addressing in the addressing table. We've done that. And then configure the branch with the appropriate addressing. Well, we just did that. So everything looks good. Now it's saying configure B1. That's the host up here. Now again, remember, this is where it can get confusing. A lot of learners look at this and they say, oh, well, B1 is supposed to be a /19. No, this is just simply a header indicating that the entire branch 1 space over here, the branch address space over here, is all in that range, but we've been asked to carve it up into 2 networks. So we're going to get on to B1, and the requirement for Baker 1 here, and we'll get over to the configuration section. It says, what does it say there? Configure B1 with appropriate addressing using the first available address of the network to which it is attached. Document the addressing in the addressing table. Now, I'm pretty certain that that is gig 00, and we're going to find out very quickly here. So we're going to use the first available IP address of the gig 00 network. So I would be looking at a 172.16.144.1, and let's see if we move, and there we go. We picked up 3 points there. Let's get our subnet correct. 240, right? Remember, it's not a /19. And then default gateway. What is my default gateway going to be? Yeah, it's going to be that layer 3 interface on the branch router, the one that we configured on gig 00 that we've got documented right over here on the right-hand side. So I'm going to say 172.16.159.254. Now, it looks a little weird, doesn't it? That is my IP address, but that's my default router? Again, these addresses are both in the same subnet, the same broadcast domain, the same VLAN. Remember, a VLAN is a broadcast domain is a subnet. They are in the same subnet, believe it or not. It's just a very large subnet that we're using here. So let's get rid of that. Let's pull up the command prompt here and let's prove it. Can I ping 172.16. What did I say? 159.254. Outstanding. I can ping my default gateway. Let me see if I can ping the other router interface. How about a 172.16.143.254? Yeah, of course, right? Because I can get to the branch router. All right, so Baker 1 is taken care of. So here we go. We're going to configure HQ and branch with the dreaded RIP v2 routing protocol. We're going to advertise all 3 attached networks. Do not advertise the link to the internet, which is this 64 address right here. Configure appropriate interfaces as passive. Set the default route on HQ, which directs traffic to the serial number. Redistribute the route to branch. Okay. So let's go ahead and knock out, since we're on branch right now, let's go ahead and get our RIP v2 taken care of. So what do we say? We say router RIP. I say version 2. I say no auto summary. And now I need my network statements. So we're going to have the 2 networks that we have over here. Remember these 2 /20s we just created, 172.16.128.0. right? And the subnet mask is 240.0. Oops, sorry, subnet mask. And then network 172.16.144.0. Is that right? 144? Yep. 144.0, and so that's the second network that's over there. In fact, I'm wondering if they said 3, so I'm assuming they're going to want 3, and then we need that /30, so I'm going to say network 192.168.0.0, and that should do it. We're not going to do anything else over here. We've got the network and auto summary. Okay, good. So that should do it on branch. Now we're going to come over to HQ. And you know what just dawned on me? Give me 1 second here. Okay, we're good. All right. I was just checking to make sure that I didn't leave off any information there. So let's get into the global config. We're going to say router rip. We're going to say version 2. I'm going to say no auto summary. We're going to say network 192.168.0.0. And it's now where we should have a rip adjacency that forms between the HQ router. So do show IP route. And now we should be learning, and take a look here. We've got the 2/20s. Right, 128 and 144 that we've learned via RIP, and it looks like, and hold on a second here, I want to make sure, because I thought it said 3 networks, but it's showing advertised all 3 attached networks. So I see 2 networks over here that I'm assuming it wants to have advertised. So I'm going to advertise those out, and let's see what happens here. So I'm going to say network 172.16.0.0, and then network 16.64.0, and I don't know if we pick any additional points up for that, because it's throwing me, it's saying 3, so I'm not sure if it wanted me to put this in to encompass the 2/20s or to put the 2/20s. And again, that is a question. So we'll see what shakes out here. Now, it said use passive interface where appropriate. Well, in this diagram, where is passive interface appropriate? Yeah, it's appropriate on the gigabit Ethernet interfaces because I don't have any RIP-speaking routers out here. So I don't want advertisements coming out to my LAN segments. And the same is true on this side. There are no RIP-speaking routers out here on the LAN segments. So all interfaces except for the serial interface should be passive. So let's take care of that on HQ first. And actually, before we do that, let me say do show IP interface brief. It should be gig 00 and gig 01, but let me confirm. Yep. All right, so we're going to go ahead and say passive interface gigabit Ethernet 00, passive interface Ethernet gigabit 01, and we're going to do the same thing over here on branch. We're going to come over here and say passive interface gigabit Ethernet 00, passive interface gigabit Ethernet 01. And again, we passive the interfaces so that they do not send RIP updates out those interfaces. Because again, there's no router on that LAN segment or those LAN segments with whom we're going to form an adjacency. Okay, so I've advertised all 3 attached networks. That statement right there is problematic. So we'll see. Maybe they don't want auto summary to be turned off. We'll find out what happens here. So set a default route on HQ, which directs traffic to the serial 001 interface. So we're going to be doing a directly attached default static route. And how do we do that? We say IP route, we do our quad zeros, and then the outgoing interface, which they've given to us as serial 001. And that's okay. We can ignore that message. We're going to get back into router RIP, and I'm going to say what? Default information. Originate, because we've got a default route here, and I apologize, I just did this on the branch router, and that is not what I wanted. So I'm going to say no IP route, get the bonus default route entry here. All right, and that actually, the extra zeros are free of charge. You can put extra zeros in at the beginning. That actually removed it. So let's pull the HQ router up, which is where we really want to do, excuse me, that static route. So we'll say quad zeros. serial 001, and now we should get some points for that. And then we go back into router rip and I say default information originate. And that's also going to be worth a few points. All right, so what I should be able to do now is come over to the branch and see that I've learned via the RIP routing protocol a default candidate route. And I've learned it from whom? I learned it from HQ, right? So there's the default route. I still have these more specific entries here, and that's fine. And now let's come over here. Okay, so now we get into the ACL portion. So design a named access list, HQ server, to prevent any computers attached to the gig00 interface. So who's on the gig00 interface here of the branch router? Yeah, it's that network /20, right? It's this network /. So this is going to be the source that we're trying to block from accessing the HQ server.pka. And this is the server we're trying to stop them from getting to. All other traffic is permitted. Configure the access list on the appropriate router, apply it to the appropriate interface in the appropriate direction. So we've been focused on standard ACLs. And so we should know, and let me see how they, okay, design and access prevent any computer. So there's the key that we're looking for. Prevent who? Stop whom? Any computers attached to that network segment, which is 172.16.128/20, right? So the question becomes, where am I going to place the ACL? If I put it here to deny traffic from everything on this network, I just blocked B1 from getting to branch server. I've blocked it from getting to HQ1. I've completely wiped out B1, anything on this network to go anywhere. If I put it here, right, that obviously makes no sense because that's going, you know, whether it's inbound or outbound, it's going this direction, right? It's this network over here that we would be messing with. I could put it here, right? But that cuts me off from HQ1. I could put it here, but that also still cuts me off from HQ1. So remember, with standard ACLs, we want to get as close to the destination as possible. So what layer 3 device and what interface on the layer 3 device is as close to this destination as possible? Yeah, here's my layer 3 device, my router. It would be that interface right there, and it's going to be in the outbound direction. So it's going to be on the HQ router that we create this, right? And we're going to apply it to the whatever interface that is. I think it's, we'll have to check. I can't remember. But whatever interface that is, we're going to apply it to that interface in the outbound direction. So let me go ahead and pull back a whole bunch of writing here that I'm hoping it's going to allow me to, and maybe that's it. All right, I think we're good with the IPs. I'm going to wipe the whole screen clean there. Okay, so let's get that ACL done up over here. Whoops, sorry. Didn't mean to move the device. All right, so we're back on the HQ router. Remember, we're going to do a named ACL. So do I say access list and then look for the name option here? No, remember, when we're doing named ACLs, I say IP access list, and then it's going to be standard, and then I give it the name, HQ server, right? Now, I'm in the named ACL the standard named ACL configuration stanza. So it's from here that I would go ahead and say deny 172.16. Now remember that gig00 interface is the 172. I was sitting here trying to remember. It's the 144.0. Now, what is the wildcard mask going to be? The first two octets are easy because it's 255, 255. But then we have 240. Whoops, 240. So what value do we get here? Yeah, we get 15.240. 255. And it's 15 because if we subtracted 240 from 255, we get 15. If we take 0 from 255 in the fourth octet, we get 255, right? So pretty straightforward. So we're going to deny that subnet. But remember, what do we have at the end of every ACL? That's right, the implicit deny any. So here I want to say permit any, right? I need to make sure I get that permit any in there so that all other traffic is allowed to flow. So now that I've got my standard named ACL and we picked up our 9 points, I'm going to get an interface, and let me do this. Do show IP interface brief, and it is going to be gig 01, if I'm not mistaken, 64. Yep. So interface gigabit Ethernet 01. I'm going to say, is it IP access group, HQ server, and what direction? In the outbound direction. And we should see a nice little bump on our points there. So we pick up 5 points. And now we've got another ACL. So we're going to design a named access list for the branch server to prevent any computers attached to the gig 00 interface on the HQ router. So if that was our gig 01, this is definitely gig 00. And there's the network that we're dealing with. It's a 172.16.64.0/18. From accessing the branch server. All right, so here's our branch server right here. So same principle, right? Here's the HQ server, here's the branch server. To get as close to this as possible, it would be on that interface right there in the outbound direction. So literally we're doing the same thing, just on the other side of our topology. So let's jump onto the branch router and let's knock this out. And actually, before we do that, I apologize. Let's do this. So from the HQ to PC, I should be able to ping. I should have tested this first. I should be able to ping that branch server at 172.16.128.1. So can I ping the branch server from HQ2? Because we want to establish that it's actually working. It is. So let me come over to HQ1 and let's try the same thing. Can I ping 172.16.128.1? Okay, so both of these PCs can get there. If I go from Baker 2 over to HQ server, and HQ server is 172.16. Where's HQ? HQ server 16.0.1. Now, should this work coming from this subnet here? Absolutely it should. And the first one timed out because we had to ARP, right? Now, what's going to happen if I come to Baker 1? Let's confirm that it's not working. Let me say ping 172.16.0.1. And look what we get. Do I get request timeout? No, I get destination host unreachable, right? So I'm getting a different message. So I think we may have to take another peek at the RIP setup here, but we're getting a destination unreachable, so we're clearly not able to get there. Traffic is not making it there. So let's finish the branch ACL here. IP access list, and this one is going to be called branch server. Branch server. I always forget the standard. All right, now, remember, I'm going to deny the 172.16.64.0, but here's where, again, these Class Bs, they cause a little concern, right? People start to freeze up because they're like, what do I do? What do I do? Well, remember, 18 network bits, piece of cake. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the next 2 bits have been borrowed to become network bits, which means 2, 3, 4, 5, 6, dot, and then 1, 2, 3, 4, 5, 6, 7, 8. All right, so there's a /18 subnet mask in binary. So when I take a look at this and I'm trying to figure out what is the dotted decimal notation for a /18, well, you could look right over here and you're going to see it, but we get 255.255.192.0. And if I subtracted this from the all 255s, I would get 0, 0, 63, 255. Right? So that is my wildcard mask right there. So let's clear the screen. Let's come back down here into control mode. And we're going to say 0.0.63.255. But then remember, I need to permit anything. And let me double check that. Is that what it said? All other traffic is permitted, right? So there's, my ACL on the branch router. I'm going to go into gig 01. I'm going to say IP access group branch server in the outbound direction, right? Because it's going to be egressing the router. It's already entered in the serial interface, and here is where it's going to egress out the router. Now, I don't think this is going to give me 6 points. My guess is it's something in the RIP config that I did. Yeah, so we're at 59, and let me check results real quick here, and it's something in the RIP config. I know it. Ah, interesting. Okay. You know, I think I've recorded this video before because this brings up an interesting conversation. So what is the problem? The problem is that they want me to passive the serial 001 interface on the HQ router, right? And let's slide this back over and let's see, did it actually tell me to do that? No, it says configure appropriate interfaces as passive. So set a default route on HQ, redistribute the branch route. Yeah, so here's my problem with points being awarded for making this interface a passive interface. And the problem is that interface, we don't have a RIP network statement for this interface. Remember, we've created a default static route and redistributed that into the RIP routing protocol. But they want me to passive this interface so that this network, that is this serial link here, and let me pull the HQ router up. So again, if I say do show IP interface brief, so what I'm saying is I think that that's incorrect that they should be taking points away for this, because we never put a network statement in for that. And you wouldn't do that, right? You wouldn't advertise the 64104. You don't do that, right? What you do is you do what we did. We create a default static, we advertise that, and we just shove it out the interface. So they're basically saying that what is missing is router RIP is that we should say passive interface serial 001. And that's going to get me the 60 out of 60. However, that statement, I don't believe, is doing anything in this scenario, because we're not going to be sending RIP messages out the serial 001 interface anyway. In fact, let me do this. Let me see. I'm going to say no passive interface. And here's how we can check. Let's debug, right? So let me say debug IP RIP. And what we should see, right, so we receive the update, and that's for the two networks over on the branch side. There's our 2/20s. But we should also see when we are sending networks. And again, I will be shocked if we're sending that 64 network, because again, there is no network statement for the 64 network. And we are not. We're not sending that network, right? If I come over here on branch and I say debug IP RIP, let's see if we're receiving the 64 network. And we'll give it a second here. Again, RIP is painfully slow, which is why it is not used a whole lot in real enterprise networks. And so you can see we're getting the default, right? But that's not that 64 network. So again, my issue with that being awarded a point is that we did not put a network statement in for this network segment right here, the 64.104.34.0. So why would I passive that interface? Because passiving an interface is so that it does not send routing updates and try to discover neighbor adjacencies out that interface. we don't need that passive statement. At least that's my opinion, is that that passive statement is not needed on this serial segment because we are not advertising that network out the serial. We're not advertising RIP updates out this interface. If we were, we would see them right now. If it was going out that interface, we would see it. But RIP is not running on that interface. So let me pull HQ up. We would see that we would be sending updates out that interface. And we're not. It's not happening, right? Because take a look. Where's the sending? Yeah, via serial 000. And we're not sending out gig 01 and 00 is because we passive those. But again, maybe it is, maybe the reason behind it, why they're asking for that, is it's a security thing. It's good housekeeping to ensure that maybe nobody puts an entry in there for that 64 by mistake. So let me go ahead and say router RIP, passive interface, serial 001. And then that gets us our 60 points. But again, I don't believe that that statement is doing anything because we are not running RIP on that interface. The process is not running on that interface. It's running on the serial 000 interface, which, perfect timing, just popped up right there. All right, well, that is going to do it for the Skills Integration Challenge. Again, a little Class B subnetting, a little RIP v2, a discussion about passive interfaces, and then some definite ACLs, standard ACLs, definitely interesting standard ACLs that we got to configure. And that does it for Packet Tracer 7412. Thanks for watching, guys, and I will talk with you soon.